Proper water analysis begins with proper sampling of the water sample itself. With the new all-weather refrigerated sampler, the user can collect either individual or composite samples based upon time, based upon flow in the collection system, or based upon upset information from water quality sensors such as pH. For example, if a water sample exceeds a nominal pH range, the sampler can be turned on and collect a sample for later analysis. Those samples can be preserved at EPA required temperatures of 4 degrees Celsius plus or minus 1 degree, regardless of weather and outdoor temperature. With the standard unit, the ambient environment can be from 32 degrees Fahrenheit, that is freezing, all the way to 122 degrees Fahrenheit in the heat of summer. With an optional controller compartment heater, the low-end temperature is increased or actually lowered from 32 degrees Fahrenheit all the way down to a minimum of negative 40 degrees Fahrenheit. This video will cover the main features of the new all-weather refrigerated samplers, those on the exterior of the cabinet and also those on the interior of the cabinet. The exterior of the all-weather refrigerated sampler is constructed of rotomolded linear low-density polyethylene. The cabinet is foam insulated where necessary, and this material provides great durability in an outdoor environment where we need to have good resistance to ultraviolet degradation. The bottom of the compartment is equipped with foot pegs on each of the 4 corners that can be adjusted up or down to level the compartment on just about any surface. Also included on the bottom of the sampler is 2 swing-out anchors that can allow the customer to bolt the controller or bolt the sampler to any foundation for a secure mounting situation. Finally, in the front bottom of the compartment is a threaded drain connection, which allows a hose to be connected, which can direct inevitable spills from the inside of the compartment away from the bottom of the sampler. The all-weather refrigerated sampler is built for life outdoors. As you can see here, the top of the compartment is sloped to facilitate drainage of any type of precipitation. The lids have been designed in such a way where no lid props or cover props are necessary. They simply rest on the back of each respective compartment. The electronics and compressor compartment includes vents with inside screening to prevent insects and other debris from getting inside the compartment. Also, the front door of the all-weather refrigerated sampler is built with very, very rugged hinges that will retain a lot of weight, especially when the door is open. And finally, the entire enclosure itself and the entire product has a variety of different certifications and conformance. Specifically, it is ETL listed, it conforms to UL standard, and it also is certified to Canadian Standards Association, or CSA. On the back of the all-weather refrigerated sampler is the compartment containing the electronics and the cooling system. The compartment is not normally accessed by the customer, and it only needs to be accessed if there is a problem with the electronics or with the cooling system. The cover is secured with 2 bolts and a couple of nuts, and the system is hinged as shown earlier in the video. Inside the compartment is the electronics enclosure and also the top-mounted compressor and cooling system for keeping the refrigerated interior of the sampler at the proper temperature. Like all other compartments on the sampler, the compartment is sealed from the exterior with a very heavy-duty gasket material, although this compartment is also vented to the exterior to allow the heat generated from the compressor to rise up and away from the compartment. Also visible is the unique gutter system shown here. Even if a little bit of water sneaks in the gap between the rear compartment and the front compartment, that moisture, water or snow, is directed away from the compartment with the gutter system. There's also a gutter on the compartment that houses the sampler itself. The gasket seals just below the gutter, so the water is directed away from the compartment itself. Now let's take a look at the two main components within this compartment. First of all, on the left-hand side is the electronics enclosure that also houses the power supply and other electronic components. The all-weather refrigerated sampler was designed and tested with user safety in mind. One example of that is the clear cover on the electronics component. Rather than having to get inside this box, LED indicators, light indicators on the inside, will be a great diagnostic tool to tell service personnel what might be the problem with the component even before they get inside the box. All of the power cords, the high voltage cords, are double insulated for safety, and this system should be trouble-free for many, many years. An optional battery backup can be mounted in this location, the purpose of which is to allow continuous sample collection even in the event of power loss. It should be noted, however, that the battery backup is only suitable to supply power to the sampler and not enough power to continue with the refrigeration and running of the electronics within the cooling system. This particular sampler is wired as supplied by the factory with a simple cable that can be plugged into an outlet, but if the customer wants to permanently wire the sampler to conduit, an electrical junction box, it certainly can be done using a qualified, certified electrician and being sure that they comply with any and all electrical codes at the location of installation. But power can be brought up inside this part and then hardwired to the controller. The heart of the compartment, though, is on the right-hand side, and that is the compressor and the evaporative cooling system that provides the refrigeration for the interior compartment. The all-weather refrigerated sampler features the only top-mounted compressor on the market, and this supplies the user with a number of different advantages. First of all, the refrigeration unit generates a lot of heat. That heat comes from the compressor and also from the evaporative cools. The heat is allowed to rise up and away from the refrigerated compartment, which is much, much more efficient than having your compressor on the bottom of your sampler, in which that heat actually works against itself by heating the refrigerated compartment, thereby making the compressor work even harder. So any of the heat actually dissipates away from the cooling system itself. Another advantage of having a top-mounted compressor is that it is isolated from things that cause problems down on the floor, such as the inevitable spills from corrosive gases and even ingress of rodents and insects that would like to kind of set up home. They're prevented from doing so with the top-mounted compressor. The interior of the compartment also features a temperature device. So this measures the temperature of the overall compartment, ensuring that the internal lubricants of the compressor are at a suitable temperature to operate. If the working temperature is very low in cold environments, the temperature sensor will detect that and automatically turn on a heat element here that is red to preheat the lubricants to allow normal startup of the compressor system. All of the copper tubing inside the refrigeration system is insulated, which prevents it from sweating. It prevents freeze-ups and any condensation that would eventually lead to corrosion within the system. One other thing is that, again, with safety in mind, there is a protective barrier for the fan blades, and while it may be hard to see, there are metal plates that are installed as a further preventative device. Even if there was a temperature overrun here, there is a barrier that prevents any hot items from touching the plastic housing and causing damage and/or a fire. This concludes the section on the electronics and cooling system with the top-mounted compressor on the all-weather refrigerated sampler. The controller compartment is on the front of the analyzer and can be equipped with either the Sigma SD900 controller or also the 900 Max. What's featured here is the relatively new SD900 controller with the spring-loaded rollers here that's very easy to maintain, and also the easily replaceable desiccant on the side. This controller on the left-hand side has 5 different connections as shown. Power from the rear electronics is supplied to the controller in the top left. On the bottom left is connection to the thermal controller. That is the refrigeration and the heating system to maintain the proper temperature on the samples. There is an auxiliary port for an external flow meter or level switch to activate sampling. And on the front, top, and bottom is a serial connection for a computer, and then also for water quality sensors such as Hydrolab sondes. The entire compartment is enclosed in an insulated lid, and even without the optional heater, this compartment can operate in ambient external temperatures down to freezing. With the inclusion of the optional controller heater option, this part here, the controller and the all-weather sampler can operate in temperatures all the way down to -40 degrees Fahrenheit. The heater is activated based upon a temperature measurement with this prong right here. That prevents the display and the tubing and everything else from freezing up with the use of the optional controller heater device. Let's now talk about the sample compartment itself. First of all, the door that opens can be locked here with keys to prevent anybody from tampering with the samples themselves. As the door swings open, you can see that this particular sampler is set up with 24 discrete bottles and a distributor arm. So in this particular case, we could take measurements and dispense and deliver those samples to any of these 24 individual bottles. The configuration inside can be anywhere from 24 discrete bottles, 8 bottles, 4 bottles, or even 1 or 2 bottles for a composite sample. Maximum volume is 5.5 gallons. The minimum volume is in the neighborhood of 350 milliliters. Those bottles can be polyethylene or glass. Notice that all of the bottles are completely recessed inside the enclosure itself to prevent any water or rain getting into the samples upon collection. When the operator is collecting the samples to take to the lab, the system is equipped with a very convenient pull-out tray. The tray is equipped with firm stops, so there's no danger of pulling the tray out too far, and the tray can be removed for cleaning. This is a nice way to take a look at the different bottle configurations. So one large bottle here for composite, 4 different bottles in each of the 4 corners, or even 2 bottles located diagonally. If we set that aside, we can see the interior of the sample compartment. First of all, the bottom is sloped down to the drain. This drain runs to the threaded drain connection that we showed previously on the bottom of the compartment. And in the interior of the enclosure, the white part is the evaporative cooler coils. This is what provides the cooling for the entire enclosure when the product is located in warm environments. Back behind the evaporative cooling coils is a heater element. So even if the compartment is located in very, very cold temperatures, that is below 4 degrees Celsius, the compartment can be warmed to maintain that 4 degrees Celsius temperature. The entire compartment is insulated with very thick foam insulation, and again, the door has a very rugged gasket to keep the compartment well insulated and efficiently cooled.